Hello there. Can you hear me okay? Well, hopefully you can all hear me okay. And I am going to be working on, or we're going to be working on the chain rule. So this is going to be a quick workshop on how to find the derivatives of composite functions and also transcendental functions. And what are composite functions and what are transcendental functions? You'll soon find out after this workshop. So the chain rule, to be able to follow our lesson or workshop for today, you need to know how to use the basic rule of the derivatives. So let's start with our first example on how to use the chain rule. So the chain rule, by definition, it is the shortcut or the derivative rule that we use to find composite or to find the derivative of composite functions. And what are composite functions? Let's say we have a of x, and a of x is 5x plus 1 quantity squared. So this is a composite function, and to be able to dissect and figure out which one is your main function and which one is your sub-function, you need to be able to recognize this like so. So if we have a of x is equal to 5x plus 1, to figure out what your main function is, let's say f of x, it's basically your parentheses squared. So usually, for it to be more visual, I usually use a box to replace the function inside the parentheses. And this is parentheses squared, so we have box squared. So this is our f of x. And our g of x, or our secondary function right here, would be the function inside the parentheses, which is 5x plus 1. So now you're seeing two functions, f of x and g of x. So a of x is actually a composite function, wherein the main function is our box squared or parentheses squared, and g of x is 5x plus 1. So let's say we have f of g of x, which is our a of x. We know that f of x is x squared and g of x is 5x plus 1. So this is the basic skill that you need to learn to be able to use the chain rule in finding the derivative of a function. So let's proceed and use the chain rule to find the derivative of this composite functions, which is 5x plus 1 quantity squared. And to do this, so we need to recognize which one is our main function and which one is our sub-function. So in this case, a of x is an f of g of x composite function, so we need to find the derivative of that. And to find the derivative of that, it's simply the derivative of f of g of x multiplied by the derivative of the inside function, which is g of x. So to work this out, so we have the d dx. This is how I visualize it at the beginning. Dx of our main function, f of g of x, which is box squared, and our sub-function, which is the function inside, which is 5x plus 1. So we have the derivative of 5x plus 1. So basically, we're performing two derivative rules or two derivatives in one functions. And for the first factor, we have the derivative of the main function, which is a box squared or parentheses squared. And this is going to be 2 times box, and then 2 minus 1, which is basically the product rule, times the derivative of 5x plus 1, and we're just going to be using the power rule for this one. So derivative of 5x plus 1 is a constant, so it's just going to turn into 0, and derivative of 5x is simply 5. So this is basically our a prime of x, which is the derivative of this function, 2 times box raised to the 2 minus 1 times 5. And if you want to simplify it, we're simply going to have a prime of x is equal to the ddx of the box squared times the ddx of the inside, which is 5x plus 1. So we have 2 box to the 1 times 5, which is basically 2 box times 5. And if we want to simplify this further, we know that the box is 5x plus 1. So by replacing it, we have a prime of x, which is simply 2 times 5, which is 10. And the number inside the box, or the function inside the box, is 5x plus 1. So this is now the derivative of your function 5x plus 1 raised to the quantity squared using the chain rule. And to have a recap of what we just did, so we have the derivative of the composite function, and to find the derivative function, this is our formula for the function. So we know that g of x is the function or the sub-function that we have, and that is 5x plus 1. And what we need to do is to find the derivative of the main function, which is box squared. Using the power rule, we know that this is just going to turn into 2 box raised to 1, but we also need to find the derivative of the inside, which is g of x, and g of x right here is 5x plus 1, and finding the derivative of that is pretty simple because using the power rule, it's just 5x. And now, yes. No problem. A good question. Absolutely. You can certainly expand 5x plus 1 to the quantity squared and then proceed to power rule. And that is basically how we're going to differentiate this if we don't know the chain rule yet. So in this particular example, you could say that it's not that useless, but most students, if they don't know how to use the chain rule yet, would divert to using the expanding the 5x plus 1 quantity squared and proceeding to the power rule. And of course, you'll still get the same result. But what I'm just showing is how composite functions works and how the chain rule works in a composite functions similar to this one. And you will appreciate the chain rule better once we have the other example for this one. So basically what we're doing is, I don't want to say shortcut, but it's just one way of finding the derivative of a composite function, because not all functions are basic polynomials, like 5x squared plus 2x plus 3, right? Some functions can be a function raised to a power, similar to this one. And it just so happens that this particular example is pretty easy to work on using the expansion method. But what if, let's say, we have 2x minus 3 quantity raised to the 5th power? We know that we can expand this, right? Yeah, we can expand this for sure. So we can just simply multiply 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3 times 2x minus 3, then perform the distributive property, and then we're going to have a very long, well, not too long, because it's just going to be a polynomial on 5th degree, and then use the power rule on each term. But of course, we don't want to do that because it's just too much. So in this case, now you will appreciate chain rule with this example, because as I've mentioned, not all functions are polynomials or basic polynomials. Sometimes we are presented with a function raised to a power, and expanding it is possible, but it just takes too much time. So let's just use the chain rule in this particular function. So to answer this, f prime of x, no problem, is simply the derivative of the main function, and we know that the main function here is box to the 5th power, times the derivative of the sub-function of g of x, which is 2x minus 3. So we have ddx of 2x minus 3. Now notice that when I am working with my derivatives, I write every little step and every little command in the rule, because for students who are doing derivatives for the first time, it's important that they know how to articulate and how they know how to use the notations, the proper notations on how the steps or commands are used in calculus, similar to what we're working on. Because back in algebra, we are just simply taught like using, or if we're multiplying two binomial, you simply use the distributive property, multiply this and that, this is equal to that, and it's okay. But when it comes to calculus, when we have multiple steps, like foreign steps like this one, it's always easier to start with understanding the notations and understanding the steps, each step that is being articulated in our process, so that you'll understand it better. So here I have the derivative of the main function and the derivative of the subfunction, g of x. So for the first part, we have 5 box to the 4th, because we're simply using the power rule for box to the 5th power. And the derivative of 2x minus 3 is simply 2. And now we have the f prime of x, which is 5 quantity 2x minus 3 to the 4th power times 2. And this is basically your answer. But since we know algebra, and we are understanding that algebra is all about simplification of your functions, so f prime of x is going to be 10 times 2x minus 3 to the 4th. And this is your final answer. Now, some students might be a little bit too excited, and some of them make this mortal sin in mathematics of distributing 10 to the parentheses, because they're so used to the distributive property without understanding that the parentheses is raised to a power. And you need to remember that when your parentheses or your function is raised to a power, you cannot simply just distribute your constant outside your parentheses inside the parentheses, because that's not the mathematical way on how we use a distributive property. So keep that in mind, because that's a common error that I see students, even in classes like calculus. So whenever a function is raised into a power and you have a constant outside of that parentheses, don't distribute it. So this is how we answer this particular problem. So again, there are two parts in this derivative process. We have the derivative of the main function f of x and the derivative of g of x, which is 2x minus 3. And then you combine both of them. As I've mentioned, f prime of x equal to 5 quantity 2x minus 3 raised to 4th times 2 is already our answer. But if you want to make it pretty, you can simplify your function into this and don't distribute the 10. Now, another important usage of the chain rule is when we have a radical function like this one. So the square root of 5x plus 1, if we take the derivative of this function, for students who don't know how to convert a radical function into an exponential function, this will be a little too foreign for them. So what we can do here is to modify our function square root of 5x plus 1 into 5x plus 1 raised to the 1/2. And now we're seeing that it's raised into a power, a function is raised into a power, so now we can use the chain rule for this particular function. And for doing that, all we need to do, just like what we have done on the two examples, is to recognize the main function f of x and the subfunction g of x. And in this case, f of x is our parentheses raised to the 1/2, and g of x is the inside, which is 5x plus 1. So now that we know our composite functions, let's proceed to the derivative process. So now I'll be writing f prime of x instead of f of x, because now I'm taking the derivative of the main function, which is parentheses to the 1/2, times the derivative of my subfunction, which is 5x plus 1. Of course, the derivative of the subfunction is easier, so let's work on the derivative of box raised to 1/2. So here, this always happens when I use this iPad right here. But anyhow, so now that we have f prime of x, which is the derivative of parentheses raised to 1/2 times the derivative of 5x plus 1, we have 1/2 1/2 minus 1. And to illustrate 1/2 minus 1, I'll write 2 over 2 because we have the same denominator, and it's a lot easier to visualize how come 1/2 minus 1 is equal to -1. So this one, I don't know what is happening with my iPad, but anyhow, let's make this quick. So we have 1/2 to the -1/2 minus 2 all over 2 times the derivative of 5x plus 1. So we have, what is wrong with my iPad? Okay, technology. I know this is crazy, but well, we know that we have very limited technology. I mean, not limited, but we have ample technology that we can use, and I'm just utilizing technology right now. But sometimes it fails us. Like right now, it's so frustrating. But f prime of x, let's do it this way: 1/2 parentheses 1/2 minus 2 all over 2 times. We know that this is 5. This is the derivative of the inside, and we have 1/2. And 1/2 minus 2 over 2 is 1 minus 2, and 1 minus 2 is -1. That's why we have 1/2 times 5. And this is our final answer, but we need to make it pretty. So we have 1/2 times 1 all over parentheses, which is 5x plus 1, raised to the positive 1/2 times 5. So our final answer here would be 5 all over 2 times the square root of 5x plus 1. And this will be our derivative function using algebra and calculus. And this is how we use the chain rule in figuring out the derivative of this function. So again, make sure that you are understanding the entire process when we are working with the chain rule, because a lot of students are confused with the chain rule because they think that it's just the power rule, but we're just multiplying the derivative of the inside. But there's more into that. So instead of memorizing steps, try to understand the concept. And the concept is that we are using the chain rule because we are working on a composite function, and the derivative of composite function needs to be differentiated this way. Okay. Michael and Roderick, since you're here, can you please give me the derivatives of these three functions? I'm going to give you 2 minutes. Yeah, don't worry. I'm not going to answer it right away, but yes. I'm going to take a little break. Do all three of them. Yeah, this is your time to practice. Yeah, tell me what your answer. How it's gonna be difficult to post it because this function is pretty long. So it's okay. Just tell me if you got it right or wrong. I'll show you the answer. Let's answer the first one. I'll work on the first one. Let's see if I can fit all three of them in one iPad. So f prime of t is the derivative of the main function, which is parentheses to the 1/2, times the derivative with respect to t of 1 minus t. The derivative of the first, or the main function, is going to be 1/2, negative 1/2, or raised to the negative 1/2, times 1 minus t. The derivative of that is negative 1. The derivative of this, to make it look pretty, is 1 all over 2 of 1 minus t raised to 1/2 times negative 1. And if you want to make this a little bit prettier, it'll be negative 1 all over 2 square root of 1 minus t. And that would be the derivative of the first function using the chain rule. Just type in yes if you got it right. And for number 2, y prime is equal to the derivative of the main function, which is parentheses to the 1/3, times the derivative of the inside, which is 9x squared plus 4. And the derivative of the first function will have 1/2. No, 1/3. This is 1/3. I'm sorry. 1/3 times 9x squared plus 4 raised to 1/3 minus 3 all over 3 times the derivative of the inside, which is 18x. And to simplify this further, we have 1/3 times 9x squared plus 4 times 1 minus 3 is negative 2, so it's negative 2/3 times 18x. Now the challenge is, do you still know your algebra? How are you going to simplify our answer to make it look pretty? By doing so, you'll be able to exercise your mastery in your algebraic skill of simplifying negative exponents and rational functions. And this will turn into, we know we can simplify 3 and 18, which is 6x. So we'll have 6x on top, third root of something at the bottom, quantity 9x squared plus 4 raised to the second power. And this is how we simplify our derivative into a prettier function similar to what we have at the bottom. Since I don't have space anymore, I'll just show you the answer for number 3. So this is for the first one, this is for the second one, and this is for the third one. And these are the answers when we are using the chain rule in composite functions. And this is basically the first part of our workshop for today, using the chain rule in composite functions, similar to what we've worked on 1, 2, and 3. And now we're going on the second half of our workshop, which is finding the derivative of some transcendental functions. And that transcendental functions will start with trig functions. So what you're seeing here, yes. Now it's okay. But here's what I would suggest to, not suggest, but as long as you have performed the derivative steps, you're good to go, because that's basically your derivatives. And if you want to make it simple, to figure out how to work on that, I have some examples on my YouTube videos, on the videos that I'm sharing on. Well, sometimes if it's a calculus video, I don't explain how, I don't explain it further, like, since this is a negative exponent, we can put it in the denominator, and since this is a fraction, we can replace it as a radical. So you may want to use my algebra videos for that. That's basically how you'd be able to understand the transformations from exponential, because what you're seeing on your derivative answer are the exponential form of your answer. But to make it or change it into radical, that's the next challenge, or basically the second level. And that is a test. So the first test is the test of your calculus skill, which is actually easy, right? It's the algebra skill that most students are having more challenging or problems in working with calculus skill like that. So, well, 13 years, it's you can get it all back like pretty quickly. Just go to the basic once again. So yeah, it'll be easier. So don't get too frustrated with that. Yeah, as long as you know your calculus, you're good. Now, what you're seeing right now are the formula for the derivative of basic trig functions. So we're seeing the derivative of sine u, cosine u, and tan u, which is basically u is being represented as your g of x, or your sub-function. So in this particular case, we're going to be using the chain rule, because we are definitely seeing composite functions when we're working with transcendental functions like trig functions. So we're going to be using all these formulas, and to be able to get comfortable with working on the derivative of trig functions, you need to master your formula first. And then once you have mastered your formula, it's basically plugging in the u function into the derivative function. So let's start with the first one. So let's say we're going to find the derivative of cosine 3x squared minus 1. So in this case, just like what we did on the first function, or the first part of our chain rule, composite function, we need to identify your f of x and your g of x. So in this case, your f of x is cosine parentheses, and your g of x is 3x squared minus 1. So now we know that we're going to be using the chain rule for this particular function. But before we use the chain rule, we need to understand that we also need to use this particular formula for finding the derivative of our cosine function, because this is not just normal or basic or regular polynomial functions. We're seeing a trig function, which is cosine quantity 3x squared minus 1. So in our formula, the derivative of cosine u function is negative sine u times du dx. So basically, this is your main function, and this is your sub-function du dx. So how are we going to do that? So d dx of cosine, let's write this out this way. Cosine 3x squared minus 1 is basically the derivative of cosine u, and the derivative of cosine u is negative sine u times du dx. So to be able to perform this derivative rule, all we need to do is to replace your u and your du dx. And we know that our u in this problem is 3x squared minus 1. And the derivative of u is 6x. So now that we have our u function and our derivative function du, we're ready to find the derivative of f of x, which is, according to the formula, is negative sine u times du dx, which is from here, we're just writing out negative sine, parentheses u, and what is our u? 3x squared minus 1. times du, and what's our du dx? It's 6x. So the derivative of f of x, if you want to simplify this further, is simply negative 6x sine 3x squared minus 1. And that is our derivative for this function. Negative 6x sine times 3x squared minus 1. Now, for those of you who are doing this type of derivative for the first time, it may be a little bit weird at the beginning, but once you get used to it, it's actually pretty simple. So, first step is to define your u, and your u here is 3x squared minus 1, and we know that we're going to be using the formula negative sine u du dx for this particular derivative. So u is 3x squared minus 1, and the derivative of that is 3x squared minus 1 ddx, or 6x. So now that we know that our u is 3x squared minus 1, and our du is 6x, we are now going to just basically replace the u and the du dx because we already performed the derivative at this point. So f prime of x is negative sine quantity 3x squared minus 1 times the derivative of 3x squared minus 1, which is 6x. So the first part is our main function and our sub-function, and our f prime of x, by simplifying it using algebra, is negative 6x times, or negative 6x sine quantity 3x squared minus 1. And this is how we find the derivative of a trig function using the chain rule. So let's see if you can find the derivative of sine 2x on your own. The derivative is right here, or the derivative formula is already here. So all you need to do is to figure out your u and your du dx, put them all together, and make sure that when you put them all together, you're using your basic algebra skill in placing all the functions in the right place. Hi, Jacob. Welcome to my workshop. Oh, thanks. Yeah, we're gonna be talking after the workshop, and let's see how we can work together on all the classes that I'm working on. And welcome to BCC. Yes, way. That's true. Oh yeah. No problem. Okay. Let's answer this because this is pretty easy and pretty quick. So here, whenever I work on derivative of the trig functions, I always write out the formula first. And again, my iPad is being difficult. So f prime of x is equal to I'm just going to copy the formula verbatim. Cosine u times du dx. And then after that, I'm going to get my u, which is 2x, and my du, which is the derivative of 2x, and du is 2. And I know that all I have to do now is to use my u and my du and replace these two items right here, and I'm done with my derivative of f of x. So f prime of x is equal to cosine 2x times 2. And that is our answer. But of course, we want to make it pretty. And to make it pretty and make it look more professional, it'll be 2 cosine 2x. My handwriting may not look professional, but how you wrote it down in this manner makes it look a little bit more simple. Okay? So hopefully you got it right. Now, let's see if you can work on this. The first function is tangent x squared minus 1, and the second function is cosecant e raised to 3x. Thank you, Roderick and Michael. I'm glad that you are participating in our workshop today. And I appreciate your attendance. You're welcome. And I'm also glad that I'm doing this workshop, even though I don't need to, because sometimes my teaching skill, my actual teaching skill can be a little bit rusty. So I'm like, okay, just give me all the workshops at the TLSC, and I'm going to be working on them just to practice my teaching skill. Exactly, because teaching and mathematics, they're the same. If you don't use it, you lose it. So in this case, I am taking advantage of the fact that I'm working or doing workshops to practice my teaching again. And yeah, it's exciting. I forgot that I love teaching. And now that I'm doing it now, oh, it's fun. I should be doing this often. Yes, it'll be the second 9 weeks. I'll be teaching statistics in the campus every day. So, and also, oh yeah, you're not in the campus Monday and Tuesday, right? Yeah, at the time, we can definitely do that. Okay, let's answer this first function, f prime of x. I'll try to write neatly. Is secant squared times u times du dx. And in this case, my goal is to find u, which is x squared minus 1, because I have done the first part of the derivative by just copying the formula. The second part of the derivative is just using your basic calculus rule, in this case, power rule, because du is 2x. And now that I have my u and du, I can complete my f prime of x, or the derivative of the function x, as secant squared quantity x squared minus 1, which is my u, times 2x. And that is our answer for the first problem. But if you want to make it pretty, f prime of x is equal to 2x secant squared x squared minus 1. And why do I want you to learn how to simplify your functions similar to what I'm doing on my answer? It's because sometimes in some multiple choice questions or in some textbooks, sometimes the answers that they're given are in this form. And you need to be aware that algebra is in the works every time you're working with a calculus problem. And some students of calculus who have very minimal or low proficiency when it comes to the mastery of algebra, they sometimes get confused with their answer and the answer in the book, thinking that they made a mistake when in fact they just didn't know how to do their algebra work, and that is what they need to work on. So for the second problem, g prime of x is, copy the formula, notice that I separate every term with a dot, which is basically factors, because all of these are just factors of each other. So now we'll find u, which is e to the 3x, and du is the derivative of e to the 3x. And the derivative of e to the 3x is another chain rule. So this is a chain rule inside a chain rule, because the derivative of e to the 3x is e to the u du dx. And in this case, you need to multiply it with the derivative of 3x. And the u right here is your exponent 3x. So the derivative of that is 3, so du is actually 3e 3x. So this is a little bit tricky if you are not familiar with the derivative of natural logarithm e, like e to the u. But now that you know how to find it, and we have the du, all we need to do is to put them all together. So g prime of x is equal to negative cosecant u, which is e to the 3x, times cotangent u, e to the 3x, times, I don't have a space, but it's 3e to the 3x. And this is your derivative for problem number 2. And this is how you work on or use the chain rule in transcendental functions similar to tangent u and cosecant u. And the second problem, it requires you to work on two derivative rules or two transcendental functions. One is cosecant u and the other one is e to the u. And this is how we're working on derivatives of composite functions and trig functions. And now, yes, it is erased already. but don't worry, because I recorded this and I'm going to upload it, and then yeah, you can go back and see how I worked it out. Oh, I have the answer already. Again, say that again. Yes, and that is correct. The derivative of e to the x is e to the x. However, in this example that we have for cosecant u, our e to the x is now e to the 3x. So essentially, if you take the derivative of e to the x, let's see. Oh, I don't have a space. Okay, let's find or use this. Okay, if we have e to the x, and we're going to find the derivative of e to the x, we're going to be using the formula e to the u du dx. So in this case, u is x, and du is 1, right? Therefore, the derivative of e to the x is simply e to the x. That's why it's, well, basically, yes, they are the same. But when your e to the x, so now our derivative function is e to the x as well. So e to the x, d dx of that is also e to the x. But if we have e raised to 7x, the derivative of that is e raised to u times du dx. That is the derivative formula for e raised to u function. So now that we know the formula, using the same concept of the chain rule in the trig function, if your u is 2x, your du is 2, right? So the derivative of e raised to 2x is 2 e to the 2x. Are you seeing the progression? Yeah. Let's say, I'll just go back because I don't have, this is weird. I cannot erase all of it altogether in my iPad. Maybe I should email Apple and ask them if they have a function to erase what I have just worked on. Okay, let's say f of x is equal to e raised to three x squared plus 5x. There. Can you give me the derivative of this function? And it's gone. F of x is equal to e raised to, what did I wrote? What did I write? E raised to, I'll just think of a different one. 3x squared plus 5x. Okay, there. Find the derivative of that. Using the formula using that formula. So now you're using chain rule for this problem. Oh, Roderick has his answer now. And I think that is correct. Okay, let's answer this. So I know that my goal is to find my u function, which is pretty easy to locate in this problem. It's the exponent. And the derivative of that is also easy to figure out because you're just going to be using the power rule, 6x plus 5. Now, f prime of x is simply copy this, e to the u, but instead of using u, use 3x squared plus 5x. Times du, and du is 6x plus 5. Of course, you want to make it pretty. So our final answer is you're seeing it now, right? And that's what most students are experiencing when they are learning the chain rule or any derivative formula for the first time. sometimes it looks funny, and sometimes it feels weird to, use the formula and do your math work similar to what we're working on right now. But that's basically it. You just have to be ready that some of your math process will be a little bit different in calculus compared to what we're used to, which is basically algebra or geometry or trigonometry. But once you get the hang of it on how the process works, it's actually very, very easy. And that is our workshop for today. And hopefully we'll have more workshop on calculus. And don't leave yet. I'm just going to stop my recording, and then we can discuss more after this recording. All right? So see you again next time. Bye.